Example 16.1 Penton turbine characteristic. Water to dry the Penton wheel is poured through the pipe from the lake, that is the lake. Okay, and indicate in the figure the head loss due to the friction to the pipe is important, but the minor loss can be neglected. Okay, including just only the major loss or the loss from the friction. A. Determine the nozzle diameter D that will give the maximum power output. B. Determine the maximum power and angular velocity of the rotor at the condition found in part A. So this is the flow from the reservoir to the through the pipe and strike the give the water jet to strike the water wheel. Okay, so in this case the beta is the 180 degrees. So this is how it looks like beta of the 150 degree. So we can start, that is the V sharp for equation for power of the turbine based on equation 1. And that is the given information phi A and B. Okay, so we start to write binary equation between point 0 and point 1. Okay, so point 0 is somewhere here, point 0 at the surface of in the reservoir, and the point 1 is at the nozzle. Okay, in this case P1 P0 is equal to P1 because it's atmospheric pressure. So we can cancel P is atmospheric pressure, and we assume that V naught is very small. The change of V naught and Z1 is on the datum, so we can cancel the V naught and not Z1, Z0, or Z1. Okay, Z1 is 0. So we can cancel Z1. So we can come up with the Z0 is equal to velocity head part plus the head loss for the equation 2. And for the head loss is equal to friction loss F over D square over 2G for, and consider the pipe diameter and the nozzle diameter not the same, so we can use the Q is to derive the equation for A1 equal to V1. A time velocity equal to A1 time V1, and the pipe velocity for pipe velocity is a ratio between the D1 equation 4. Okay, and next we substitute the equation 3 and 4 in equation 2. Okay, so we got the Z0 is equal to V1 square over 2G plus F over D. Okay, we can rearrange this equation to get 1 plus the F over D, and D1 over D is power 4, and time velocity head. And from this we can rearrange the equation for V1. Okay, square root. Okay, next we can substitute some number in this equation. Z0 is 60. In this case, given the friction factor is 0.2, the length is 300, diameter is 0.2, and 40 is 0.2. So we get the number is 33.3 and square root of 1 plus 1,000, 80,000. So we got the equation of the V1 is a function of D1. Then we form Q is equal to substitute in equation 1. So we got the U sharp is equal to rho pi over 4 U subtract V1. Substitute number in this equation. Next we substitute equation 6 in substitute V1 in equation 6 from equation 5. This equation is a bit long process. Substitute V1 from equation 5 in equation 6. The power is equal to substitute number in okay. In this case, if we want to get the maximum power, we have to substitute that U maximum power is equal to V1 divided by 2. So V sharp is equal to 15 10 power 6 D1 power 2. Okay, so we have the function of power is a function of the D, but the maximum power you have to find by differentiate V sharp with the diameter D1 equals to 0, so we can estimate what is the maximum power. So for the Okay, it's quite a long process to get the differentiate w dot respect to d1. Okay, then finally we can show that the what is the d1 for is equal to 1, and we prove that v1 is equal to okay, so it's 0.7, 0.07. We can, in this case, if we want to try with the curve like this, we can plot between the velocity u and the v sharp, so we can get that the for we can try the different d by numerical, and we can prove that d1 is the to get the 0.07 to get the maximum power. Okay. Okay, let me move to part B. Oh. So what is the maximum power for this case? Just substitute the diameter is 0.07. So the maximum power is 42 watt. Okay. U is equal to omega times radius is equal to V1 divided by 2 half. Omega is equal to V1 divided by 2R. Okay, we can prove that the angular velocity should be 31.6 radian per second. And we can convert to if we multiply by divided by 2 pi and multiply by 60. Okay, that is the so we got the 302 rpm. Okay, convert from radian per second to rpm. Okay.